Hello, good afternoon. My name is Jeroen van Ham. I'm working for the sensor division of TDK, overlooking our global sensor portfolio. The title of my presentation is Sensors for the Coming Energy Revolution. And actually, it's better to say for the ongoing energy revolution. We're actually right in the middle of it. We're seeing the worldwide CO2 reduction targets, getting away from fossil fuels to electrified solutions. There are a lot of geopolitical tensions at this moment with the EU ban of Russian oil. We're also seeing, in general, a global trend of electrification. And also there, we need new types of sensors to support this. And just knowing that by 2050, the global world population will have grown by 2 billion people, this will put us for some serious challenges in terms of electrification and supporting this. So today, I want to speak about, first of all, sensors that we need to create these new types of energy, and secondly, sensors that we need to support our ongoing consumer shifts and the need for electrification. So let's turn back the clock for 3 years. Looking at what happened in the early 20s, there was already years of underinvestments in gas and oil sectors. Compared to 2014, the investments were 50% lower. So we were already a bit sleepwalking into a crisis without knowing it. Then we had, of course, COVID, early 2020. And after the COVID, we had this economic recovery, more demand for oil and gas. And then, of course, as everybody knows, February 2022, we had the invasion of Russia into Ukraine. And that meant a lot. Look at this graph. So I remember that I was contacted by my gas company in July last year, saying that the gas price I would have to pay would be 7 times higher. Unfortunately, it didn't came to that ultimate point, but everybody became aware of the importance of energy. And that was actually one of the first time we started thinking of the importance of energy. Also, governments today, they struggle with what we call the trilemma. First of all, they have to make sure there's a security. Our homes get heated. Secondly, the affordability. We can heat the homes, but not at any price, of course. And thirdly, sustainability. To reach the Paris goals, the 1.5-degree global warming, we have to make sure we do things. Today, we're on track for a 2.5 global warming. But anyhow, people became aware there are investments, a lot of investments actually. If you look at what will happen up to 2025, a lot of the investments are going into wind energy. Of course, solar is also a very important one. And then we have other sectors like energy storage and also electric vehicle charging infrastructure. If you look today, we have in Europe 200,000 chargers that need to go up to several millions in only 10 years' time to support this. So this is what we have in terms of capacity today, 2022, and then going up to 2050, you see that in terms of energy storage, we will add more than 2,000 gigawatts of capacity. In terms of wind energy, almost 4,000 gigawatts. And in terms of solar energy, more than 6,000 gigawatts of energy. And this fundamentally changes the way how we deal with energy and energy storage. Now, TDK supports this revolution and how we're going to these new energy challenges and tackle them. Basically, we have a vision of 7 Cs within TDK. You see them here. 2 of the 7 Cs are directly related to tackle the specific challenges we'll see in the coming decades. First of all, renewable energies, and then, of course, also the consumer shift to mobility, electric vehicles. And this is fully in line, of course, with the sustainability goals of affordable and clean energy. So maybe TDK at a glance. First of all, TDK was founded in 1935. We started with magnetics, inductors as core materials. And maybe some of you remember the cassettes from the 1980s, 1990s. That meant a big deal for TDK. We went further on magnetic heads. We have a lot of magnetic technologies like TMR technology, Hall technology. But gradually, we start evolving more towards power supply, battery management, and also batteries. Many people don't know that TDK is one of the major suppliers of consumer batteries today. In 2010, 2015, there were quite some acquisitions in the sensor and actuators fields. And finally, we're focusing always and keeping our eyes open on next generation components. Today, the focus is on sensors. This is the global portfolio of TDK, where we tackle the challenges for new energies. We have 2 booths here at PCIM, at Sensor and Test, but you see that it's quite diverse, going from magnetics, passive, active components, power supplies, etc. But let's focus on the sensor products and see how they add to the specific challenges here. We basically have 3 types of sensors. So we have the temperature pressure sensors, including thermistors, temperature sensor systems. We have a group focusing on magnetic sensors, TMR, Hall sensors, angle, positioning. And then we have a group focusing on MEM sensors. That's more IMUs, microphones, barometric pressure sensors. Now, looking at the energy revolution, I want to discuss 3 things today, going away from the old energies we know today to renewable energies. The first shift we're seeing is the creation of energy, where we'll focus on wind power, how sensors are involved there. Secondly, going to electrification of mobility. As I said already, we will need a lot of chargers. We will need a lot of sensors to support this. An electric car today, electric car has 3 times the amount of sensors compared to an internal combustion engine car. Yeah. And finally, also the heating of our homes. There we see a shift from the traditional gas-based systems to heat pumps. We will have 2 billion more people in 2050, and the electricity needs will triple. So we need to be able to support this. Sensors in energy generation. Let's first look at wind power. So today, the largest wind turbines can produce about 14 megawatt of power. Typically, the ones you see beside the roads are a bit smaller, 1.8 megawatt up to 4 megawatt, but they still are pretty large, pretty dominant. And one of the key areas that I want to discuss is preventive maintenance, especially when it comes to offshore turbines. This is extremely important. So looking just at a wind turbine, if you look at the infrastructure and the several steps, you need, of course, NTC sensors, thermistors in the windings to control the temperature and the heating. You need position sensing of the generator, of the gearbox. And then you need also additional sensors to control not the core mechanism of the wind power, but making sure it behaves as it should be, vibration sensing inclinometer. To explain that, there's a big difference between onshore wind turbines and offshore. Offshore, they're not built on solid ground. They're built on a platform which is artificially created. And you have to take into account to build this, about 30% of the cost of the global installation is just in creating the artificial platform and creating the base. Now, what is very important, and we see a steep rise in those type of sensors, is that we need to measure whether the wind turbine has a perfect vertical position under all circumstances at sea. To do this, you need what we call an inclinometer, but not just a standard one. You need one with an extremely high resolution, 50 micro-G, which is also stable over time and over temperature, to identify possible ground infrastructure problems. This is a product we supply, which you can also have a look at our booth. The second thing which is important with wind turbines, and especially offshore wind turbines, it's very hard to control the actual conditions. You do not send workers over there every month. It is just too expensive. But there are mechanical issues that can occur. Mainly 2 types of issues. You can have a failure of the bearings, and you can have a misalignment and imbalances in the gearbox in the generator. Now, just to place that into context, if you have to replace a bearing, it will cost you between 5 and 10K. If you have to replace the gearbox and a generator, we're talking about 250K up to $500,000. So the cost is huge. You do not want to reach that point, and therefore we do what we call condition-based monitoring, preventive maintenance. You need a special type of sensor for that. And again, you can do it at different stages. If you look at the failure mechanism over time, it always starts with vibration. Then you start seeing fluctuations in the power that is generated, noise, heat, smoke, and that's a point where we do not want to get. Then it's already too late. So we want to capture the failure as early as possible in the vibration stage. Now, to do that, you need a high frequent vibration sensor. It's not sufficient to have a 2 kilohertz vibration sensor. You really need to go up to 10, 20 kilohertz to really detect the fine differences in the normal behavior. So this is a product that it's a 20 kilohertz vibration sensor, specifically targeted for those kind of failure detections. It has a 20 kilohertz range. It is programmable. And again, the low noise density is only 25 micro-G. It also attaches very easily to the infrastructure, can output with an M8 connector. This is not the only product. We also supply complete modules, complete systems with also other types of sensors, depending on the specific needs. Another application where we need specific type of sensors is what we call geothermal drilling. Today, this is not a dominant energy source, but it's rising. And it's a way to basically capture thermal energy from the ground. Ideally is that you do not have to drill very deep, but you have a high geothermal gradient. That's the ideal situation. Now, to reach that, you need to drill into the ground for several hundreds of meters up to a few kilometers. Of course, there's no GPS reception under the ground. So to detect the exact position, you need a specific type of gyroscope. A gyroscope to define basically the north and where you can deduct the exact position into the earth. We do that for geothermal drilling, but it's also very useful for mining of new materials. If we look at supporting the electrification, there's a lot of fuss about mining new materials like lithium, cobalt, and to do this, you need specific gyroscope that are able to detect the position in the ground. Very low bias instability and average random walk below 0.1. Another type of energy is, of course, solar energy. There we see the main influences on the sensors, especially in the terms of thermistors for the inverters that are used. Of course, we have current sensing technologies, which are, by the way, useful across all the different types of markets that I'm discussing today. We see a trend towards battery health monitoring to make sure that you can control the battery health by measuring temperature and pressure inside the cells of the battery. What we also see is solar panels. They can lose a lot of efficiency when they collect dirt. So there's a rise in what we see solar cleaning robots, which contain IMUs, inertial measurement units, time of flight to detect distances, temperature sensors, magnetic current sensors. Another application in solar energy are these type of panels, large-scale solar trackers that follow exactly the position of the sun. To do this, you need a sensor that can measure the exact position of the panel. You can do it by measuring an angle versus the y-axis, or you can do it with an accelerometer. Today, we see most interest in these type of industrial 3-axis accelerometers to detect exactly the position of the panel. Then finally, I also mentioned it already, current sensing. It is important across all the type of technologies we see here for battery sensing, for solar, for wind. We have several types of current sensor. One you see at the top is a Hall sensor-based device. So it has basically a Hall plate, and you can place it into a concentrator coil. Very cost efficient in size, power requirements. We also have closed loop systems, which in terms of linearity and resistance to saturation have typically better performance compared to Hall. Now let's make the step to the sensors we will need in the future to support the consumer shift, sensors for electrified mobility. We see a big difference if you compare the situation today to 20 years ago. We see a trend of micromobility, steps, e-bikes, e-mopeds, but also electric vehicles. By the way, by the time we reach 2025, we will reach the point that the demand of raw materials will exceed the supply. So there's a need for recycling. Also, that's a very important topic we look at for TDK, but especially here in terms of sensors, there's a huge shift going on from traditional powertrain sensors, internal combustion engines, to sensors needed for electrified vehicles. So looking at the e-bike, generally you see a shift from the sensors you have in cars also being used at bikes. I'm just taking out a few examples. We have sensors determining the exact gear position. We're seeing a shift in going to electric gearbox shifting. Also in the battery pack, there are more sensors included to guarantee the safety. We have IMU sensors, we have angle current sensors in the system. So there's a lot of sensor on a typical bike which is sold today. Of course, automotive, this is where a lot comes together in terms of sensor portfolio. I will not go into detail on every single sensor, and this slide is not even including the sensors we need for ADAS, like camera systems, like radar system, LiDAR systems. But you see a lot is going on, not only in cabin, but also for the drivetrain, for the chassis type of sensors. Okay. So just bear in mind, by 2030, 1 on 3 cars that will be solved will be an electric vehicle. So the sensor market is basically growing with almost 10% over the next 10 years across different domains. One domain which is not well known to the public is that of thermal management. It's one of the main challenges the car makers struggle with today because it's totally different than an internal combustion engine car. About 50%, 55% of the battery is going to driving the car, but a lot of the energy left is going to heating the car, heating the battery, bringing the battery to the optimal temperature. So the focus of OEMs is really on this. And why is it important, thermal management? Not only for the comfort inside the cabin, but also for the charging speed of the battery, for the battery life, for the driving range and the efficiency. And you see, if you turn on your air conditioning, if you turn on the heater, you cannot use the energy that comes normally from the motor of a traditional car. You need to create the heat with a traditional heater based on electricity, and this consumes a lot of power. So here you see the traditional system for an ICE. Your motor is just generating heat. It's not an ideal motor. It does not have a high efficiency. It automatically drives the air conditioning compressor just by rotating. In a battery electric vehicle, you have to run all of this from the battery. The in-cabin comfort, creating the heat, but also the battery thermal management for the battery itself to maximize efficiency and safety and the lifetime of the battery. So how does it work? Well, first of all, you have quite some sensors, mostly temperature and pressure, to regulate the cooling liquids in the car, to regulate the heat transfer and to spread it out over the battery. So in the battery, you have different sensors and in the cooling chain around it as well. Now, sensors alone is not enough. You also need actuators and valves to control the liquids, to control the direction of the cooling fluids. And these specific types of valves, of course, they need to be steered, but you also need to measure exactly the position of the valve. So that's what you see here. Across the cooling system, heating system, you have a lot of types of valves. And if we zoom in, you see that it's typically built of a position sensor, which knows exactly the opening angle of the valve. And secondly, you have a high voltage motor control to control very accurately the opening of the valve. And it's in these types of control systems that you can really make the difference and make the thermal management system as performant as can be. So thermal management, it includes, of course, thermistors. We have a lot of different thermistors at TDK, but actually one of the key competences and differences with competitors is the way we create the designs to fit exactly the end applications. We have a lot of in-house production on specialized form factors to fit exactly to the pipes you need, the battery pipes. Everything is different. Depending on where you measure the temperature, you need a different way of attaching the sensor to the surface. Then also in terms of pressure sensors, in a car, you have a lot of pressure sensors combined to traditional ICEs. You have a different goal for these pressure sensors. One is, of course, to detect thermal events, thermal runaway into battery packs. Of course, you need also pressure sensors, flow sensors to measure the coolant liquid. And then finally, we have combined pressure and temperature sensing, which are directly placed into the refrigerant cycle. And you see they all come with different ranges. They all come with different temperature needs. Some have to withstand extremely high temperatures, 180 degrees, but it really depends on the application. So it's clear that this thermal management, it poses a lot of challenges for the sensor community and also for sensor manufacturers like TDK to make sure we follow these trends and can deliver the sensors that are needed to support this. I want to touch upon the last subject, which is residential heating. Today, the most common way of heating a house is still with a traditional older heating system, I would say. So a fuel oil based system or a gas based system. Today, we mostly see those type of systems, a condensing boiler. But we're going towards heat pumps more and more, electrified systems where you basically make use of the energy available in the ground and you translate that into the heating within the house. So basically you have a few different sources. You have air-to-air heat pumps and air-to-water heat pumps that basically convert the outside air to heating inside air or heating inside water. You can also work a ground source with pipes in the garden or water source that is less used. But residential systems typically are in these regions up to 10 kilowatt, 20 kilowatt. And you see, if you look just at the numbers, these type of systems are rising up to 2026. We'll see a rise of about 10% in these systems. And also in terms of absolute market size, there's a big increase in heating pump systems. Now, again, what do you need? Which sensors do you need to support this? If you look at the typical infrastructure for these type of systems, you have at one side the heat source. Depending on which you use, you need a different type of sensor in terms of UV resistance. You have the heat pump system and then the heat dissipation inside the house. Every sensor, and I just pasted here a few examples, have different form factors because you can have the temperature cell, but that's not enough. You need to make sure the pressure is right to the pump, to the cycle. You have to make sure that the contact is right, the material. So that's where the actually knowledge is of delivering temperature type of sensors. So to conclude, TDK is supporting the energy revolution. For TDK, basically, it is two of the strategic 7 Cs, which focus on supporting the energy revolution. We do not only deliver active and passive components, magnetics, but one of the business groups which is growing the most is actually the sensor business groups. For us, this is important. Also, TDK Ventures is one of the groups within TDK that looks at strategic investments of startups. It's focusing a lot on the energy revolution. So recently, earlier this month, we did a strategic investment into a company that works on recycling lithium technology. As I mentioned, within a few years, we will reach the point that the raw materials will have to be recycled. Otherwise, we run into issues. So I invite you all to visit us. We have a booth at PCIM where we demonstrate our products, and we have a booth here at Sensor and Test, not far from here, where we focus specifically on sensor solutions. You can have a look at the magnetic sensor solutions, so TMR, Hall technology, temperature and pressure sensors. We have Tronics showing their gyroscopes and accelerometers. And finally, we also show our ultrasonic sensors. Thank you very much.